Okay, new topic, graphing quadratic functions. Now I want you to set up an input-output table for the x and y variables. X is the independent variable, y is a dependent. Now we're just going to pick 7 numbers for x. Let's just go 0 in the middle, then 1, 2, 3, then -1, -2, -3. Now you can pick anything you want, but that's how I'd like it done. Okay. Now y equals x to the second power. So I'm going to write x to the second. That does not mean 2 times x. So what you're going to do is scribble out the x and replace it with 3. So 3 to the second power, that means 3 times 3. That's what 3 to the second means. That's 9. Now I want you to do -3 to the second power. Okay? It's not -9. What's a negative times a negative? See, I'm going to replace this x with -3. I just put a -3 there. What's a negative times a negative? It's a positive. It's +9. I don't care what your calculator says with the caret. A negative to a second power ends up as a positive. So 9, 9. So now get rid of your x and put 2 in. 2 to the second power. That means 2 times 2, and that's 4. Okay. Now put your -2 in for x. -2 to the second power means 2 -2's multiplied together, and that's +4. Okay, 1 to the second, it's not 2. 1 to the second is 1 times 1, and that's 1. Okay. Now -1 to the second is +1. Now if I put 0 to the second, okay, in the middle, 0 times 0 is 0. Now graph those, okay. So this is the x, this is the y-axis. So I go to 3 on x, 9 on y. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 4. So I go 2, 1, 2, 3, 4. 1, 1. 0, 0. -1, 1. -2, 1, 2, 3, 4. And -3, 9. This makes a u, okay? When it makes a u, that is known as a quadratic function. Now this point in the middle, see that point right there? That is known as your vertex. I want the vertex labeled, okay? That is 0, 0. It's a point in the middle. This is the vertex point. Now you're going to learn something. It's called the domain and range of a graph, okay? Now the domain, you notice how there's arrows on both ends of the graph. So the domain is all. That means you can put anything in for x, okay? X equals all. That means I can put any number I want in for x. But the range is your y, okay? But you can't have anything for y. So you go to your y coordinate 0. Now I want you to look at all of these other points here. 0 is the lowest it gets. All the other points in the y column, 1, 4, 9, 1, 4, 9, those are bigger than 0. So we put a greater than or equal to 0. Okay? I want that filled out. Now, rather than have to do all these powers every single time, this is known as your parent function. Okay? It's called the parent function. Now I want you to tear off this sheet, and every time I have y equals x to the second in this assignment, it's going to change, okay? When we have just an x to the second power, no other x, okay? What I want you to do is put that in parentheses, please, okay? So first we just start with y equals x to the second. Now I'm going to make the table that I just had, okay? I'll worry about the +5 after I get my input-output set up. 3, 2, 1, 0, -1, -2, -3. Now I already know putting 3 in and taking 3 to the second power gives me 9, okay? And then the -3 is 9. Putting the 2 in gives you 4, and then 4, 1, 1, and then 0, 0. Now, that parentheses I made, is this +5 inside or outside? It's outside. It's called a k value, okay? outside. If we have a function outside, it does the same effect to all of your y outputs, same effect to y. So you're going to add 5 to every single one of these outputs. So 9 plus 5 is 14. 4 plus 5 is 9. 1 plus 5 is 6. 0 plus 5 is 5. And then it goes 6, 9, 14. So what it does is it moves the graph up. Okay? So the x, I'm good to go by ones. 1, 2, 3. -1, -2, -3. But the y's, we got to now reach 14. So on the y-axis, you're going to number by 2's. 2, 4, 6, 8, 10, 12, 14. Okay, I don't need to do the negatives. So 3, 14, right there. 2, 9, right there. 1, 6, right there. 0, 5's between the 4 and the 6, okay. -1, 6, -2, 9, -3, 14. So now your parabola, the u, when you compare it to the parent function, it's the same shape, it's just shifted upwards, okay? So this point in the middle is the vertex, I'd like that labeled, okay? 0, 5, the middle point, because now you do your domain and range. Now x is always all. There's no restrictions on what x can be. You can put in any value for the x variable you want. But now the y does not go beyond 5. Now look at these other outputs, 6, 9, 14, 6, 9, 14. Those are greater than 5, so greater than or equal to 5. Okay. Domain's all on all of these problems. Y equals x to the second power minus 3. So put that in parentheses, and let's make the table for the parent function, where it's just x to the second. Because I start there, 3, 2, 1, 0, -1, -2, -3. And I know that putting that there gives me 9. Now I know there's a minus 3. 4, 1, 0. You can just copy them. 1, 4, 9. Now, outside of the function, we have a minus 3. That's called a k value, and those k values outside produce the same effect to the y outputs, all of them, okay, not just one of them, so minus 3. So 9 minus 3 is 6. Now we have to take 4 minus 3, 1. 1 minus 3 is -2. 0 minus 3 is -3. Then I'm back to -2. And then 1, and then 6, okay? Because 9 minus 3 would be 6. Okay, so x, 1, 2, 3, -1, -2, -3. Now on the y-axis, I have to get that to 6, so I can go by 1s on that. So 3, 6, I don't need a number by 2s on either axis. 2, 1. 1, -2. Okay, 0, -3, so 0, 1, 2, 3, and then -1, -2, -2, 1, and then -3, 6, 1, 2, 3, 4, 5, 6. Okay, so now you see how your u coordinates, now it's continuous, okay, you can have decimals in for x, which is why we connect them, we don't just leave it in the points without the connection. Okay, so label your vertex point, and then that's the middle, and that's 0, -3. X is 0, -3. Okay, the domain's still all. Now we put y with -3. Now I want you to look at these other y values. They're bigger than -3, so again, greater than or equal to -3. Okay, whatever you have in for y, it's got to be bigger than -3, and it eats a bigger number. Okay. Okay, next problem. Now, we don't have to make the parentheses, it's already there, okay? But it's still x to the second. This plus 4 is now known as an h value, not a k value, because it's inside, okay? Outside is k, inside is h when you're talking plus and minus. Okay, so x, y. Put in the parent coordinates, okay? 3, 2, 1, 0, negative 1, negative 2, negative 3. Now, you're just going to ignore the plus 4 and x to the second. So 3 to the second is 9, and this is 9, 4, 4, 1, 1, 0. Now, an h value is inside of the function, okay? Inside does the opposite to the x, okay? Opposite to the x. So what is the opposite of, so I go to the x column, what's the opposite of plus 4? Minus 4, okay? Now, I don't have anything outside. You're like, well, what about that 2? That's the power, okay? This is the power here. There's nothing being added or subtracted outside of the function, so the y stays now. Now, it's the x we change. So 3 minus 4 is negative 1. 2 minus 4 is negative 2. Negative 3, negative 4, and then negative 1, negative 5, negative 6, negative 7. Now we are not changing the y because that plus 4, we add the x to the second power, but the plus 4 is now inside, making it the opposite to the x. The y stays put. Okay, so I can make ones, so I go left 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I go left 2, 1, 2, 3, 4. Then negative 3, 1, 1, 2, 3 up 1. Negative 4, 0, 1, 2, 3, 4. Negative 5, 1, 1, 2, 3, 4, 5 up 1. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And then negative 7, 9. So negative 7 and then 9's all the way up here. Okay. So inside the function, an h value, when you look at that in comparison with the parent function, moves it right to left. It moves it horizontally by doing the opposite to the x. Okay, so label your vertex point. It's that one in the middle. So negative 4, 0. X is still all, okay? Now the y is 0. But all these numbers are bigger than 0, so it's greater than or equal to. Okay. Next one, y, we got the x to the second power and a minus 5 inside of the function, so that is an h value, and it's inside. Inside does the opposite to our x. From the parent function, I mean. So I set up the parent function as though it was just x to the second power. So 3, 2, 1, 0, negative 1, negative 2, negative 3. Okay, 9, 9, 4, 4, 1, 1, 0. You're just taking all those numbers to the second power. Now, opposite to the x. So I go to the x. What's the opposite of minus 5? It would be positive 5. So that's 8, 7, 6, 5, 4, 3, 2. And the y stays the same because the x is second, that the operation's inside the function. Okay, so 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 6, 1. 1, 2, 3, 4, 5, 6, 1. And then 5, 0. 1, 2, 3, 4, 5. That's an x-intercept. It's on the x-axis. 1, 2, 3, 4, 1. 1, 2, 3, 1, 2, 3, 4. And then 2 back up to 9. Okay. So again, h values move the graph this way. K moves it up and down from the origin, the parent function. Okay, so 5, 0. Your x, y. Domain still all. Now with y, you take the 0 that you have there, and again 1, 4, 9, 1, 4, 9, so it never gets below 0, so it's greater than or equal to. Okay, y equals the quantity x plus 2 and then minus 5. Now, pretend we got two operations, one inside, one outside. Okay, so let's just do our parent function first. Okay, as though I'm pretending as though it was just y equals x to the second power. Okay, so 3, 2, 1, 0, negative 1, negative 2, negative 3. So 3 to the, ignore all that crap, just write y equals x with the second power. The plus 2 minus 5 we'll do later. So 9, 9, 4, 4, 1, 1, 0. Okay. Now we have something inside that's an h value and this is a k value. So remember, inside the plus 2 does the opposite to the x. So I go to the x and I do the opposite of plus 2, minus 2. Now I have another operation, the minus 5. That's outside. That's a k value. Outside does not the opposite but the same to our y outputs. Inside's opposite to x, outside same to y. Okay? Okay, so opposite to y, the same to y, so the minus 5, we put minus 5. Now 3 minus 2 is 1, 2 minus 2 is 0. 1 minus 2 is negative 1, 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. Negative 2 minus 2 is negative 4. Then we subtract 2 from negative 3, negative 5. Okay, then 9 minus 5, that's 4. 4 minus 5 is negative 1. 1 minus 5 is negative 4. 0 minus 5 is negative 5. 1 minus 5 is going to be negative 4. 4 minus 5 is negative 1. And 9 minus 5 is 4. Okay, so graph them. So 1, 4. 1, 2, 3, 4. 0, negative 1. Negative 1. Negative 4. 2, 3, 4. Negative 2. Negative 5. That's your vertex. Then negative 3. Down 4. Negative 4, negative 1. 1, 2, 3, 4. 1, 2, 3, 4. Negative 1. And then negative 5, 4. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. Okay, so you set your parabola. Label the middle, the negative 2, negative 5, that's your vertex. Okay, so domain is all. The range, y, just put your negative 5, the one in the middle. And these points are bigger than negative 5, so again, it's greater than or equal to. So every y I have, it could be equal to negative 5 or anything greater. Okay. Okay, next one. I'm going to just write y equals x to the second. Okay. And I'm just going to do the parent function. Okay, parents on that first page. 3, 2, 1, 0, negative 1, negative 2, negative 3. So 9, 9, 4, 4, 1, 1, 0. Now, this is an h value, this is a k value. Okay, so inside does the opposite to the x, opposite operation. Outside does the same to the y. Okay, so opposite to the x, so that's going to be plus 4. Then outside you have minus 3. Now you don't switch that to plus, that's outside, it does the same to the y. So that's going to be 7. 2 plus 4 is 6, 1 plus 4 is 5, 0 plus 4 is 4. Negative 1 plus 4 is 3, negative 2 plus 4 is 2, negative 3 plus 4 is 1. Now 9 minus 3 is 6, 4 minus 3 is negative 1, or 1, positive 1. 1 minus 3 is negative 2, 0 minus 3 is negative 3, 1 minus 3 is negative 2, 4 minus 3 is 1, and 9 minus 3 is 6. Okay, so 7, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Then 6, 1. 1, 2, 3, 4, 5, 6, 1. Remember, this is x, this is y. 5, negative 2. 1, 2, 3, 4, 5, 1, 2. 4, negative 3, 1, 2, 3, 4, 1, 2, 3. then 3, negative 2, 1, 2, 3, 1, 2. 2, 1, 1, 2, up 1. 1, 6, 1, 1, 2, 3, 4, 5, 6. Okay, so there's my parabola. And we label the vertex. Okay, that's the middle, the 4, the negative 3. You can clearly tell it's 1, 2. This point here is what I'm going off of. 1, 2, 3, 4, negative 3. Okay. Alright, so all is your domain. Now range, you take the middle y, negative 3, and ask yourself, these numbers where it curved up, they're bigger than negative 3, all of them. So it's greater than or equal to negative 3. Okay, next one. Let's just go y equals x to the second so we can get our parent function set up. So 3, 2, 1, 0, negative 1, negative 2, negative 3. So 3 to the second's 9, and negative 3 to the second's 9. 4, 4, 1, 1, 0. Okay, now inside you got a plus 6, so that's an h. That does inside, remember what it does. It does the opposite to the x. Outside, you have a minus 4. Okay, that's a k value. Those k values, they're outside. They do the same to all of our y outputs. Okay, so inside does the inversely, oppositely affects the x, and the outside does the same to y. Okay, so inside minus 6 because it's plus 6, but outside it's still minus 4. So 3 minus 6, negative 3. 2 minus 6, negative 4, then negative 5, then negative 6, and negative 7, then negative 8, then negative 9. Okay, 9 minus 4 is 5. 4 minus 4 is going to be 0. 1 minus 4 is negative 3. 0 minus 4 is negative 4. 1 minus 4 is negative 3. Then you're going to be 0, and then you're going to be 5. Okay, that's how a quadratic function behaves. Okay, so negative 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Negative 4, 0. 1, 2, 3, 4, and that's an x-intercept, meaning it's on the x-axis. Negative 5, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. Negative 6, negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. Negative 7, negative 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Negative 8, 0 is on the x-axis. It's another x-intercept. And then negative 9. 1, 2, 3, 4, 5. Okay. Alright, so there's my u. Okay, so the domain is all. And the range, you put your y, and you put that middle point, the negative 6, negative 4, right there. You don't really put negative 6. Negative 4 is your y coordinate, the one in the middle. And all these other y coordinates are bigger than negative 4, so it'd be greater than or equal to negative 4. Because any number we put in for y, if we put a 5 in for y, it eats the 5, okay? If we put a 5 in for y, it eats the 5. You put a negative 3 in for y, it eats a negative 3, because all those are bigger than negative 4. Okay, last one. Again, this is an h, this is a k. We're just going to start with y equals x second, then we're going to transform the graph to meet the criteria in the equation. So the parent graph, 0, 1, 4, 9, or shoot, that made no sense, okay. 0, 1, 2, 3, negative 1, negative 2, negative 3, and then 9, 4, 1, 0, 1, 4, 9. Okay, so h is inside, okay, the insides, those have to do the opposite to the x, the opposite. Okay, outside we got a plus 3. Those outside operations do the same to the y. Okay? So inside we got minus 4, so we do the opposite, plus 4. Here I'll even put plus 4. Opposite's the same to the y, so put plus 3. Okay? So plus 4 to the x, plus 3 to the y. Opposite on that one, same on that one to the y. So 3 plus 4 is 7, 2 plus 4 is 6, 5, 0 plus 4 is 4, negative 1 plus 4 is 3, 2, 1. Okay? Now 9 plus 3 is 12, 4 plus 3 is 7, 4, 3, 4, 7, 12. Okay, now we can go by 1s on the x, but we have to get to 2s on the y. So the x's can go by 1s, but when we do the y's, we have to count by 2s. And if I have to count by 2s, I'm going to number by 2s to positive 12. 2, 4, 6, 8, 10, 12. Okay, so 7, 12. 1, 2, 3, 4, 5, 6, 7, 12. 6, 7. 1, 2, 3, 4, 5, 6, 2, 4, 6, 7. 5, 4, 1, 2, 3, 4, 5, 2, 4. You can go by 1s on the x, 2s on the y. 4, 3. 1, 2, 3, 4, 2, and then 3. 3, 4. So 1, 2, 3, 2, 4. 2, 7, 1, 2, 2, 4, 6, 7's right there. Then 1, 12. So 1 and then 12. Okay, label your vertex point, please. That's the middle. 4, 3. Or excuse me, I did that wrong. No, I did it right. Okay, 4, 3. Just this middle one here. So all is your domain. Now with the range, you put y with 3. 4, 7, 12. 4, 7, 12. All the y's we get are bigger than 3, so greater than or equal.